happening. So you quickly do this. This is a 4 mark question. Okay, start doing. Okay, anyone who has got the answer, be quick. All right. So you have to find the work done by the car as it decelerates. The formula for work done is force into distance. Force is equals to mass times acceleration. Acceleration is change in velocity over time. So this is a three-step question and you are easily going to get the answer. Okay. Please solve it and let me know if you, yep, simple. Okay, step up. Hopefully, we'll be starting with nuclear physics, or we'll be doing something about magnetism. I'll decide once the class starts, like officially the class starts. Acceleration is v minus u over t, so it's deceleration. It's 13 minus 0 divided by the time is 2. So this is coming out to be 6.5 meter per second square. Okay, just ignore the minus sign. Now let's find the force. F equals to ma. Mass has been given to you as 1350 times 6.5. Answer, please. Mm-hmm. Where's force into acceleration? No, no, no. The force into acceleration. Just the answer for this. 1350 times 6.5.
8775.
It's A775. And then we are going to have work done. Force into distance. The distance has been given to us as 13 meter. So we finally got our answer as it's going to be, yeah, 114,075, which can be approximated as 1.1 10 to the power 5 joules. Okay. Two of the papers which I have seen, Summer 22, paper 4142, and Summer 21, paper 41 and 42. I've seen some questions which are trickier. So just guys go into this, okay? For O levels as well, you should attempt your Summer 22 papers. They're trickier. Please do attempt and come up with the questions which you are not able to do. Okay. All right. Okay. This was the first question. Let's start the class the topic at 6 PST. So we've got another 11 minutes and we can practice some more questions. Let me check on some very tricky questions. I just extracted a few of them. So okay. Space physics is just going to be happening. Okay. So who is going to tell? I expect an answer from you guys. Electricity is transmitted at high voltage. Explain why high voltage increases efficiency even with thinner wires. Let me write down this question. This is another 3 mark question. Electricity transmitted at high voltage. Explain why high voltage increase efficiency even with thinner wire. So my dear students, what's happening when current is flowing? So what happens that at high voltage, when there is a greater voltage, so what is going to happen that if voltage is high, okay, so current is low. When current is low, what's going to happen that you are going to have less amount of heat produced and we will have more efficiency. Okay, so you can say at high voltage, current is less, so less heat produced and यूजी से नहीं है कहीं नहीं गए wait okay I want you guys to write down this answer. All of you must write down first and then tell me what you have written. So this is a conducting sphere with an insulating stand. You have brought a positive charge rod in front of it. Okay. And this is an a uncharged conducting sphere with an insulating stand. Okay. So describe how to charge the sphere using wire connected to earth. And explain whether it is going to be positively charged or negatively charged. I've just written the question over here. Can you see it?
Sir, हेलो सर।
जी.
सर आंसर आपको व्हाट्सएप पे सेंड करें?
You can write down and we're going to discuss. I'll ask randomly to anyone what you have written. Be quick. Got it. Okay. Zenabeta, can you ask Ali to join as well? Okay. Let's start. I think we should start with Shazin. Yes, Shazin, beta.
Sir, I'm still writing. Almost done.
Okay, okay. If Abdurrahim is done, you can tell. Umar has written and sent the answer as well. Okay, if you guys don't want to tell, you can just send the answers. This is the positive order is negative ions inducing an earth wire on the other side. We can extract all the positive ions, leaving only negative. So there's no. Sure. Good. So what about the positive charges? Like, are they going to go somewhere or they're going to stay in? So basically, we are going to have all the positive charges have gone to the other side of the sphere. Okay. And when we are going to attach an earth wire, so the earth wire is going to bring more negative charges from the earth. So it's going to be negatively charged. Getting? You remember we studied two different scenarios. One was that when we have a negatively charged rod, so the negatively charged rod is going to attract all the positive charges. Okay. So negative charge, positive charges will be there. And then when we bring the earth wire, so the earth wire is going to, what it's going to do, earth wire is going to take away all the negative electrons towards the earth. Okay. And leaving behind all the positive charges. So the sphere is going to be positively charged. Okay. So in this case, what's going to happen that when you are going to bring out, okay, let me just draw this again. So when once you have just brought this, so all the negative charges are going to get attracted over here, and the positive charges are being repelled and being sent to the other side of the sphere. This is an insulating stand, so it does not allow charges to go through it. So what I have done, guys, remember this: the positive charges never go. Okay, so the positive charges never go. This is a 3-mark question, so you have to write in detail. When you place the earth wire, so earth wire, because this is positive, so it's going to get more electrons coming from the earth, and these electrons are going to neutralize the positive charges, and excessive negative charges are going to travel from the earth. For instance, if there are 5 positive charges and 5 negative charges initially, now there are 10 negative charges. So 10 and plus 5, so the overall answer is -5. So the overall charge on the sphere is negative. Please do not write that positive charges will be sent to the ground. You'll get a 0 because they have already specified in the marking scheme. Don't give a single mark to the student who has written positive charges move. They do not. Is this clear to all of you?
सर मुझे समझ में नहीं आया
मैं पढ़ा चुका हूँ तुम्हें पहले, इतने डिटेल में पढ़ा है दोनों केसेस. ये भूल गए? एक दफा दोबारा बता दें, जरूर बता दें यार, कोई मसला नहीं. Just be with me, my dear students, मेरे प्यारे प्यारे बच्चों. Look here. Case number 1, you are bringing a negative charge rod. ठीक है? And case number 2, are we going to have Ramadan next? No, I don't think so.
Next week is 24, right?
Uh-huh.
Yeah, then it'll be during the week, I think.
No, I'm talking about the physics lesson.
Oh, okay.
Okay, just look here. Case number 1. Case number 1, what's going to happen when you have put a negative charge rod, so all the positive charges will be attracted over here and negative charges are sent to the other side. Okay. Now, remember, when I have put a negatively charged rod, I want it to make positively charged. And when I have put a positive charge rod, so I want to make my sphere negatively charged. This is the thing. The sphere is going to have the charge that is opposite to the charged rod. Now, what I'm going to do to make it positive? Okay, I'm going to connect an earth wire. Okay. And because it's negative, so negative is going to repel negative and all the electrons will go. to the ground. Okay, so when all the electrons go to the ground, so what's going to happen? Now you're going to slowly remove the earth wire, but you are going to place this. Okay, this rod is still in place. This is step number 2. Okay, and then finally you're going to remove it, and now you are having the positive charges spread evenly all over the sphere. Is that clear or not?
सर अभी थोड़ी
Yes.
सी दिक्कत
वापस अमान समझ आ गए?
जी सर थोड़ा सा दोबारा एक्सप्लेन कर दें
थोड़ा सा दोबारा एक्सप्लेन कर दे. No problem. बेटा देखो, what's happening over here is that we have a sphere which is uncharged. Okay, the sphere is uncharged. It does not have any positive or negative charge. It's neutral. When we just put the negatively charged rod in front of the sphere, all the positive charges are going to be attracted towards the negative side, and negative are going to be put to the other side. Okay, I want the negative charges to go. I want it to be positively charged. So I'm going to place an earth wire where the negative charges is. Negative charges are going to go towards the ground. Okay, so when negative charges have all gone away, so what's happening? You are left with positive charges. Now what you're going to do? You have not removed the rod so far. The rod is still in place, and then finally you just remove the rod, and the positive charge is going to spread out evenly all over the sphere. Is it clear?
यस सर
All right. Case number 2. G Habiba, is that clear or not?
जी सर clear.
All right. Case number 2. Now you have put a positively charged rod, so it's going to bring all the negatively charged. Okay. So I want it to be negatively charged. What I'm going to do? Should I remove all the positive charges? No, positive charges won't go. So I'm going to have the earth wire over here. What the earth wire is going to do is going to bring the electrons, because this is positive charge. So it's going to say, oh, come on. All the electrons from the earth are going to be asked to come in. Okay. So now what is going to happen? Sir, we are having positive charges over there, and you are saying I have to make it negatively charged. I can only make negative charge when the positive charges are going to go away. So how they're going to go away? Only when you have excessive electrons. Okay, so in this case, positive charges never go. So what you're going to say? Electrons, or you can say negative charges, excessive negative charges from the sphere, sorry, from Earth, enters the sphere, and overall charge on the sphere is negative. Okay. So you can say excessive negative charges from Earth enters the sphere, which cancels out the positive charges. Just add it over here and cancels out positive charge. Okay. So the overall charge on the sphere is negative. I hope it's clear now. Alhamdulillah, that's great. Okay. So let's start with the new topic, and most probably mechanism Umar aa jao tum वापस inshallah, then we'll start. Okay, so हाँ तो 1 घंटे तक क्लास जाती कब है? 1 घंटे में 6 UAE time. हाँ, that's fine. I'll do that. Okay, nuclear physics, one of the most important topic. Okay, and like most of like a few students in the class, they have already studied that with me as well, and they've got good ideas. Just to have a recap, and ones who haven't studied this so far, it's a new topic for you guys, so just be with me. In nuclear physics, we are going to study about the radiation, okay, or what we can call radioactivity. Nextly, we are going to talk about the different forms of radiations in the form of alpha, beta, and gamma particles. And we are going to talk about nuclear fission and fusion. Nuclear fission and fusion. And For my O-level students, you have got a few more detailed topics like the nuclear reactor that's not there in the IGCSE syllabus. So I'll just give a brief overview of that topic as well. CRO cathode ray oscilloscope is also there in the O-level syllabus. There are a slight differences, okay? So I'll just make you guys learn about that as well. So just don't worry. Nuclear fission and fusion, okay? We are going to talk about background radiation. We are going to talk about the decays, alpha, beta, and gamma. We are going to talk about uh, the effect of electric and magnetic field. Effect of electric and magnetic field. We are going to talk about. We're done with that. We're going to talk about the Rutherford experiment, and then we are going to talk about. Finally, we're going to talk about the half-life, and we are talking about the half-life, and we are going to talk about. This is all. This is all. So this is the whole thing. What is left over? Okay, that's it. So it's a very interesting topic, and most probably the second last question from all the papers is from this topic. So you guys must know about this. So what is this topic all about? That heavy nucleus. Heavy nucleus. You get the notes for this. You'll get the notes for this. Heavy nucleus are unstable. So because they're unstable, they want to become stable and they split it up. They split their nuclei, and what happens? Radiations come from them. So when basically the nucleus is splitting and or the nucleus is joining, that's fission and fusion. So radiations just get emitted from them. So the radioactivity is basically the spontaneous emission of radiations from a spontaneous emission of radiations from a radioactive source. This is what you call radioactivity. Okay. So in radioactivity, there are two very common phenomena, which is the nuclear fusion, and the other one is nuclear fission. Nuclear fusion is the combining of atoms. Smaller nuclei are going to get combined together to form a larger stable nucleus. But this is not a very common process. Just think about that. The two hydrogen atoms are going to combine and form a helium atom. And that requires so much amount of energy because it's not a bonding. It's basically combining the two nuclei, center to center. It's not the electron getting somewhere. It's the whole nucleus mingling. So this requires loads of energy. So nuclear fission is fusion is basically the combining of smaller nuclei So it's basically the combining of smaller nuclei Okay, so my dear students, you might be asked to write down a 3-mark question for nuclear fusion. So in nuclear fusion, what's happening? That atoms are going to combine together, okay, and smaller unstable nuclei are going to join to form a larger stable nucleus with the release of energy. This is nuclear fusion. Next is nuclear fission. Nuclear fission is splitting of a heavy unstable nucleus into smaller stable nuclei with the release of energy. In both the cases, energy is released. So you guys can be asked to write down about the nuclear fusion equation. So we are going to have, who's going to tell what are isotopes?
Same number of protons and electrons, but different numbers of neutrons.
Yes, the same number of protons, but different number of neutrons. Okay, so isotopes of hydrogen, they're going to react together and they're going to form a helium atom. Okay, so this is the equation you need to remember about nuclear fusion. So 2H1 plus 2H1 is going to produce helium, that is 4He2, and energy is released. This equation can be asked to write down and you'll get 2 marks for this. Okay. One question. Can nuclear fusion happen at the surface of Earth?
No.
Reason? Yeah, reason?
No, because it's too much energy.
Exactly. Okay. So this is another possible question. So for nuclear fusion requires extremely high temperature and pressure. Okay. So it cannot happen at the surface of Earth. Okay. Nuclear fusion occurs at the core of sun. Okay. You must remember this. All right. Like hydrogen is mixing and producing helium. Okay. Okay, just be with me. There can be another equation for this fusion. 2H and 1H. Okay. This can be also happening. So, my dear student, just remember that the proton number and the neutron number, they are going to be the nucleon number, they are going to be balanced out on both sides of the equation. So, if these two isotopes are being given to you and you are supposed to write down the complete equation, so you're not going to write 4He2, it's 3He, okay, 2. So, this is helium. Now, the question arises, sir, what are you doing? First, you have written 4He2 and then you have written 3He2. So, my dear students, you must remember an element is identified by its proton number, not by its nucleon number. Many different elements can have same nucleon number. So, just look at that. They both are having 2. So, that means they both are helium. These are the isotopes. Okay. So depending on which hydrogen atoms are combining together, you can have the helium similarly. Okay. So both of these equations can be there. Is this clear or not? Mhm. Okay. Okay. So what is happening? Why this energy is from where are we getting this energy? So this energy is coming out from like the ones which are mixing together. Some part of their mass is converted into energy. So that means the ones which are being mixed, they have larger masses slightly as compared to the ones which are produced. So some of the mass is converted into energy. And because there's so many different atoms combining together, so this energy sums up to be a very big amount of energy. All right. Like from where this energy is coming? We are saying energy is released. How comes? So some of the mass of the reactants is converted into energy. Walaikum salam. Hydrogen are combining together. They are fusing. Some part of the nucleus, because nucleus has mass. Neutrons and protons have mass. So the parent nucleus, which is mixing, will have greater mass as compared to the daughter nucleus, which is produced after fusion. Okay, that's what I've told. Okay, nuclear fission is basically the splitting of a high heavier nucleus into smaller ones, and we have energy release as well. So in nuclear fission, what happens that we are going to have a larger nucleus, and it's going to hit smaller ones. Just look here how the fission occurs. So for fission, so this is the larger nucleus. Okay, it's going to split up, and these ones are going to split up. So this is called a chain reaction. Okay, so in a nuclear fission, what's happening? That a larger nucleus is splitting up into many smaller nuclei. Okay, can you move on?
Yes, sir.
All right. So the emissions which we are having from the radioactive source can be either of the three types. So we have got alpha particles, we have got beta particles, and we have got gamma rays. So alpha particles are basically helium atoms. What do I mean to say? That if a radioactive element is losing energy and that is in alpha decay or alpha particles are emitting, so basically that means that helium atoms are coming out from that radioactive element. Okay, so alpha particles are basically helium atoms, and it's 4He2. Alpha particles have positive charge. They have highest ionizing power. and they have got lowest penetrating power. And they can be stopped. क्या?
जियाद ने
जियाद ने पिछले हफ्ते ये पूरा पढ़ा है मेरे साथ, एक ही क्लास में पूरा पढ़ा है इसको रिवीजन कर रहा था, स्कूल में टेस्ट था तो इस वजह से। चलो okay. So alpha particles are basically helium atoms. Number one, positive charge होता है इनमें, highest ionizing power और lowest penetrating power. ये क्या चीज है? Ionizing power and penetrating power. अल्फा पार्टिकल्स जैसे ही रिलीज होंगे ना, एयर मॉलिक्यूल्स के साथ स्ट्राइक करेंगे, ठीक है, और एयर मॉलिक्यूल्स के साथ स्ट्राइक करके वो उसको आयनाइज कर देंगे। स्मोक या डस्ट पार्टिकल्स के साथ वो रिएक्ट करके उनको आयनाइज कर देंगे, यानी उनके इलेक्ट्रॉन्स रिमूव करवा देंगे। तो इसका मतलब ये है कि अल्फा पार्टिकल्स जैसे ही रिलीज होते हैं, दे गेट स्कैटर्ड, दे आर नॉट स्ट्रॉन्ग इनफ टू मेक देयर वे एंड पेनिट्रेट इनटू समथिंग। ओके, इज इट क्लियर और नॉट?
पेनिट्रेटिंग पावर का मतलब क्या है?
पेनिट्रेटिंग पावर का मतलब ये है कि टू एंटर समथिंग। इसको इमेजिन करो, पानी आ रहा है दूर से, वाटर इज कमिंग विद अ वेरी हाई फ्लो, ठीक है, आपने उस वाटर के ट्रिब्यूटरीज निकाल दी, 4-5 जगहों पे उसको डिस्ट्रीब्यूट कर दिया, तो इसको समझो कि ये आयनाइजेशन हो गई। will it have the same power to go and penetrate or enter or something? No, because you have deviated it. So in the same way, when as soon as alpha particles are released, they just travel a few centimeters, they react with the air molecules and they get scattered, they ionize them. So that's why they have the least penetrating, highest ionizing power and least penetrating power. ठीक है, स्मोक डिटेक्टर जी, हाँ जी। आयनाइजिंग इज बेसिकली एक न्यूट्रल आपके पास मटेरियल है या ऑब्जेक्ट है या फिर एक न्यूट्रल एटम है, उसमें से जब आप पार्टिकल्स को डिस्चार्ज कर देंगे, उसमें से इलेक्ट्रॉन्स रिमूव हो गए, इट बिकम्स एन आयन। ओके, अब क्योंकि अल्फा पार्टिकल्स की इस कदर कम जो है पेनिट्रेटिंग पावर है, तो आप उसको अपनी स्किन से या फिर जो है एक शीट ऑफ पेपर से स्टॉप कर सकते हो, ठीक है। अच्छा, पहली बात अल्फा पार्टिकल्स आर नॉट हार्मफुल बिकॉज दे कांट पेनिट्रेट, बट दे आर एक्सट्रीमली हार्मफुल इफ दे डू पेनिट्रेट। हाउ कम्स? सबसे पहली बात तो वो पेनिट्रेट करेंगे नहीं, मगर if they do penetrate, just imagine they have gone inside and they start ionizing the particles inside the human body. They're going to destroy the cells. Okay? All right. So that's why they are harmful as well, but not to the extent because they do not penetrate. But if they do, they are deadliest. Alpha particles basically use हो जाते हैं, it's a good question, smoke detectors में use होते हैं, फायर अलार्म्स के अंदर, स्मोक डिटेक्टर्स के अंदर। लेट मी टेल यू मोर यूजेस ऑफ दैट, अ वेरी गुड क्वेश्चन। They are used in smoke detectors, they're used in the treatment of cancer, oil industry, they're used to in the field of heart pacemakers. Okay, तो इसका जो सबसे बड़ा काम है वो स्मोक डिटेक्टर्स का है। मैं बताऊंगा, स्मोक डिटेक्टर्स पढ़ाऊंगा बेटा आपको। और ठीक है, तो इसके एप्लीकेशन अगर देखनी है, यू कैन जस्ट गो टू यूट्यूब एंड सर्च ओवर देयर द यूजेस ऑफ अल्फा पार्टिकल्स। तो हमारे सिलेबस के अंदर स्मोक डिटेक्टर पहले हुआ करता था, बट नो मोर, बट मैं आपको पढ़ा दूंगा क्या होता है। देखिए, देख लो यार, तुम क्या याद करोगे। This is a smoke detector, ठीक है। Radioactive source is in the center. which is emitting the alpha particles. Okay. As soon as alpha particles are going to get released, air is coming and going to interact. Okay, like air में smoke है, ठीक है? So what it's going to go as air flows, alpha particles ionize air molecules. हो गया? Air के अंदर smoke था, smoke particles are smaller, okay, than air, and they're just going to hit and they're going to interact with alpha particles. Alpha particles ने air molecules के अंदर जो smoke particles उनको ionize कर दिया. Once they are ionized, अब वो ions बन गए और ions जो हैं यानी कि electrons release हो गए. So electrons release हो गए. Those electrons are going to travel through the metal plates. Metal is a good conductor. Circuit लगा हुआ है. Bell ring होगा या फिर beep होगी. From there you can know that there is smoke. Okay. I'll share these notes with you. Okay. Like मेरी भी थोड़ी
सर तो अल्फा पार्टिकल्स स्मोक एयर के अंदर जो स्मोक होती है उसको आयनाइज करते हैं.
जी बिल्कुल उसको आयनाइज करते हैं because they're smaller, okay, and then they can be easily ionized.
ओके.
तो देखो इंसानों ने कहाँ जाके चीजें सोची हैं, they're just using it. Okay, so beta particles are fast moving electrons and they are electrons. Like अगर किसी में से beta particle निकलेगा तो उसमें से एक electron निकलेगा only. Okay, one electron is beta particles are of two types. Inshallah, you're going to study this in your A levels. For the time being, you just need to remember that beta particles are fast moving electrons. They have negative charge. They have lower ionizing power and a strong penetrating power as compared to alpha particles. And they can be stopped by a few millimeters of aluminum sheet. So if you just place aluminum sheet in place of them, so some of the beta particles can be stopped, or most of them can be stopped by placing an aluminum sheet. Okay. So alpha particles are stopped by a thin sheet of paper, but thin sheet of paper cannot stop beta particles, so they are going to pass through it. But as soon as you put a few millimeter of aluminum sheet, so they are going to stop your beta particles. Okay. They are going to penetrate. They're going to penetrate. Okay. Finally, we have got gamma rays, and gamma rays are gamma rays. Okay. Gamma particles नहीं क्योंकि इनका कोई mass नहीं है. They're just they're photons, high energy light rays. They're just going in. Okay. They're neutral. They have the highest penetrating power. ये ionize नहीं होते. जिस तरह source से निकलेंगे वैसे ही जाएंगे, and they're going to strike and penetrate. So they are used for chemotherapy. They are used for detecting of PET scanning के अंदर use होते हैं gamma rays. So इनके बहुत सारे uses हैं. ठीक है, medical purpose में industries के अंदर. So so highest penetrating power, lowest ionizing power. They can be partially blocked by lead block. Partially, not fully stopped. ठीक है, because they are highly intense. Is that clear? Okay. Now you guys are going to tell this. I want this answer from who is going to tell. Aman, you tell us, okay? And the rest of you must be prepared for your turn. Which one is alpha, which one is beta, which one is gamma among these three rays, which I have drawn with the colors? Am I audible? Okay, answer please. कोई भी बता दे. Okay,
Yes, sir.
done. Okay. All right, so I'm sharing these notes with you on the group. Some of my students already do have these notes, so please just go through them. We'll be back in 10, so we can carry on the class. It's already there now. So all of my students must go and see this. I'll resend it. Just let me resend this. Give me a second.